Hey guys, we're moving into thermodynamics right now. So we're going to go through sort of this definition stuff. Thermo means heat, dynamic means movement. So what we're looking at here is the movement of heat, which is kind of weird if you think about it, because what exactly is heat? So we got to think about a few things here. Temperature, it's a measurement, it's not an amount. So it's a way that we measure heat, but it doesn't tell us exactly how much heat there is. Heat is a form of energy. It's transferred between objects at different temperatures. So we understand this: if something hot touches something cold gets warmer, and something hot gets colder. And that's we're going to look at that more in depthly when we look at equilibrium, or sorry, not equilibrium, calorimetry. Thermal equilibrium is when two objects come to the same temperature, and a lot of things do that. So if you have like a small glass of water and really hot piece of metal or something like that, and you put metal in the water is going to heat up and the metal is going to cool down until they're both at the same temperature, or thermal equilibrium. Energy, this one's kind of hard to define. If you think about what energy is, it's a really strange concept. We're always trying to get more, we need more, we use energy when we turn on our lights and stuff like that. In physics, it's the ability to do work. That's what energy is. All right, and what's work, what's force over distance, but don't worry about that. In chemistry, you can have gas expansion, which is how like a car engine works. The gas expands and it takes the piston and it moves it, and that's how the car moves. Also, it's in temperature changes, and we're going to focus on temperature changes right now. We're not going to so much do gas expansion. We're going to start with heat equations, which really isn't that hard. Then calorimetry. Next, enthalpy is kind of a weird word, and then bomb calorimetry. So here we're going to start with heat. Its symbol is Q. I don't know why, but its symbol is Q. So there it is. Q equals M times S times delta T. That is it right there. Mass is in grams. Specific heat capacity, that's something that is, we're going to jump into right out here. And then delta T is change in temperature. That's the important thing. It's a change. It is not the temperature. So if something goes from 10 degrees to 20 degrees, delta T will be positive. If it goes from 20 degrees to 10 degrees, it'll be negative. That's okay. You can have a negative change in temperature. So specific heat is right here, specific heat capacity, that's our S. It's the energy needed to change the temperature of 1 gram by 1 degree Celsius. It's very specific, all right? If you have a low heat capacity, uh, then it's very easy to heat things up and cool things down. Metals have very low specific heat capacities. High, this is difficult to heat up or cool down. This is like an insulator. Anything that's an insulator is going to do this. Or water actually has a really high specific heat. It's different for every substance. So like this is something that you'll be given. So don't think that this is something that you're going to have to memorize or anything like that. One example of specific heat would be if you go to the beach in the summer, the sand gets really hot, and then at night the sand gets cool pretty quickly, but the water pretty much stays the same temperature because it's really difficult to heat up and cool down water. And here, all right, calorimetry. Um, calorimetry is a way to measure how much heat moves between things. We're going to talk about a specific type of calorimetry last, the bomb calorimeter. That's how we figure out how many calories are in food. So here you have your system, which is what we are interested in, and surroundings, which is the rest of the universe. And I will continue this on the next video.